Hi, now let us look at the continuous random variable. A random variable x is said to be a continuous random variable if it can take all, that is infinite number of possible values between the certain limits. For example, weight of a person, height of a person, age of a person. In most of the practical problems, continuous random variable represents the measured data such as all possible temperature values, all possible heights, and it should be noted that the sample space of the continuous random must be continuous, it cannot be discrete. So further, the probability function, which is a mathematical function that provides the probability for all possible values or all outcomes of a random variable, is defined by the probability density function, so the PDF. So if x is a random variable, then we define its probability function by a probability density function. Consider a continuous function f of x and consider a small interval of length dx, that is from x to x plus dx, and fx is some continuous random variable of x, so that f of x into the small interval dx represents the probability that the random variable x falls in the infinitesimal small interval dx, that is x lies between x to x plus dx. Then f of x is called the continuous random variable of x. So the properties of the probability density function, that it is always greater than equal to 0 for all possible values of x, and the integration of f of x over all possible values of x is 1, that is area under the PGF is 1, and the probability that x lies between a and b is can be determined from the probability density function by integrating the probability density function from a to b. And it should be noted that for the continuous random variable, the probability at any point, that its probability that x is equal to a is 0. That is, the probability at a point is always 0 for all possible values of a. And let x is a continuous random variable, then the cumulative distribution function. So the cumulative distribution function is defined by capital F of x, and it accumulates all the probabilities less than or equal to x. And if x is a continuous random variable with PDF f of x, then CDF is defined by the probability that x is less than equal to x, and it is determined by integration of f of x from the minus infinity to the variable x. And the probability that x is greater than a and less than b is the distribution function at b minus the distribution function a of a, where the capital F is the distribution function of x. And we can determine the PDF from the CDF by taking its derivative with respect to x. And further, the mean and variance of the continuous random variable x are also important parameters, and the mean of continuous random variable is denoted by mu, and it is the expected value of the random variable x, and is determined by the integration of x into f of x over all possible values of x. Further, the Second movement of the random variable is called the mean square value. It is the expected value of x square and is determined by integration of x square into f of x over all possible values of x. And the variance of the random variable is denoted by sigma square, and it is calculated as expected value of x square, that is the mean square minus value minus the square of the expected value of x. Now let us look at the example of continuous random variable. The diameter of an electric cable x is assumed to be a continuous random variable with probability function f of x. So this is the PDF of the random variable x, and is equal to 6x into 1 minus x, and the x lies between 0 and 1. And determine a number b such that the probability that x is less than b equal to probability that x is greater than b, and also find its cumulative distribution function. So what is given to us, that the probability of x less than b equal to probability x is greater than b. So if you want to calculate the probability that x is less than b, then it will be determined as integration of, here it should be noted that the possible value of b lies between 0 and 1. And so the probability x less than b is given by the integration of f of x from 0 to b equal to integration of f of x from b to 1, because the maximum value is 1. So to calculate this, we substitute the f of x. So 0 to b, 6x 1 minus x dx equal to b to 1, 6x is 6 into 1 minus x dx. So if you integrate this, you will get 6x cube by 2, 6x cube by 3. So from 0 to b, again 6x cube by 2 minus 6 cube by 3 from b to 1. If you will substitute the limits, both the limits, you will get the cubic equation 4b cube minus 4b square plus 1 to 0. So this cubic equation can be factorized using the factoring method, and you'll get as 2b minus 1, 2b square minus 2b minus 1 equal to 0. So the b equal to, so it is 2 equal to 0.5, and solving this quadratic equation will get b equal to 1 plus minus iota by 2. So b is 0.5 is the only possible value that satisfies these limits. So we discard this value and consider b equal to 0.5. So next is find the cumulative distribution function. So to calculate the distribution function, so we'll write, so the distribution function f of x is equal to integration from 0 to x f of x dx equal to 0 to x 6x1 minus x dx equal to 6x squared by 2 minus 6x cubed by 3. To write the distribution function properly, in proper way, you write it as, so the distribution function is 0 for x less than 0, and it is 3x squared minus 2x cubed for x less than 1 and equal to 0, and it is 1 for x greater than equal to 1. So this is a cumulative distribution function. Thank you.